Hello, geometry students. I hope you made it through the last part of your week all right and that you're having a good weekend. These are the notes for Monday's class. I saw in the classroom that somebody took it upon themselves to erase Thursday and Friday's information from the calendar, including the note that there were notes for this weekend. So if you have friends that may be counting on the board not saying they had notes as going to be their reason why they don't bother to do them, you might want to send them a text and let them know that that is not going to cut it, that the notes will be due on Monday, just like the board had said before some fool erased it. Anyway, let's get started. Our objective for today is the student will learn special vocabulary and properties applying to isosceles triangles. Now, some of you have kind of gotten a little bit lax on taking your notes. First off, we do them in Cornell format, whether you like it or not, so please make sure you are doing them in Cornell format, and it is not acceptable to simply skip copying down the objective and the date. That is part of the deal, so please write down the objective. The date for Monday will be November the 18th. Press pause anytime you need more time, and hit play when you're ready to move on. Okay, now obviously, as the title suggested, we are focusing on isosceles triangles, and isosceles triangles are of particular interest since they have so many of the properties that we have been talking about, and some that we have not even been talking about yet, all in one figure. Now, we have mentioned the term isosceles before. Okay, and the definition that we came up with for isosceles was that it has at least two sides congruent. Okay, now that obviously has many possible applications, and the definition of at least two sides congruent is an accurate definition, but the diagrams we're going to focus on today are going to be figures that only have two sides congruent, but that does not mean that the properties that we're going to talk about today, that doesn't mean that they don't apply to like an equilateral triangle and such. Okay, but the diagrams will simply only have two legs congruent. All right. Now, before we look at the properties that all isosceles triangles carry, we're going to need some basic vocabulary for the structure of our triangles. Okay, so let's take a look at some new terms that you may or may not be familiar with. Okay. In an isosceles triangle, we have, of course, three sides. Now, the two sides that are congruent to each other are what we refer to as the legs of the triangle. And the third side, or the side that is unique, okay, the one that's different from the others, is what we call the base of the triangle. You may have heard this vocabulary before. Okay? If so, that's good. Just a review. Okay? And there is a possible example of what an isosceles triangle might look like using the vocabulary of legs and base. There is one thing I need to caution you about, however, and this is a kind of a resonating thing, something you're going to hear over and over with in geometry, and that is the term base. Okay. In the English language, when we think of a word like base, base typically means bottom. It means something that is usually sat on by an object, like the base of glass or the base of a statue, stuff like that. Okay, it's the underneath part, the part that stands or holds everything standing up, holds everything up. Okay, but in the geometric language, the word base has absolutely nothing to do with being on the bottom. The diagram that I just showed you that had the two red legs with the tick mark and the one blue base could have just as easily been drawn exactly like this one is drawn. It would not change the fact that the two congruent sides are the legs. The side that is different is the base. Okay, so do not fall into the trap of thinking legs always stand upwards and base is always flat and on the bottom or anything like that. It's a common misconception. It's something that test writers do like to pick on because they know that sometimes geometry students do not pay a whole lot of attention to the differences between the English language words and the matching geometric language words. So why we got to pay so much attention to our vocabulary. Okay, so let's move on. In an isosceles triangle, our legs of the triangle are going to join together. The location where the two legs of the triangle join together is called the vertex of the triangle. Okay. So using the first diagram that I gave you, which you can go back to the original diagram that you drew and add this label into your diagram, and it is the vertex. Now, this is a rather unfortunate vocabulary occurrence, and it is not the last time that we are going to see such an unfortunate occurrence. We have discussed the term vertex before. Okay, a vertex is a corner point where two sides of a polygon join together. Okay, now that is still absolutely the truth. A vertex is still where the two sides of a polygon join together. In this triangle that we are looking at, there are three vertices, which is the plural of the word vertex, three vertices in our isosceles triangle. Okay. However, there is only one location in the figure that is referred to as the vertex. Okay, and the vertex is the location where the legs join together. So the other two vertices down by the base, those would not be what a problem would be looking at if it happened to refer to the vertex. So it's unfortunate that the vocabulary is so similar. However, that is the deal. So we'd better get it sorted out in our heads, because this is going to be a problem if we do not know the difference between a vertex and the vertex. Okay. Moving on. In an isosceles triangle, okay, where the vertex of the triangle is, an angle is formed by the two legs joining together. That angle is called the vertex angle. Okay. So if you drew your triangle large enough to begin with, you might add the vertex angle into your diagram. Okay, we're going to actually add a couple of more names for angles into your diagram. So if your first diagram was so small that you cannot write inside of it, go ahead and draw yourself a new triangle now that has some extra space so you can label some angles inside of it. Okay, but the vertex angle is, of course, the angle near where the vertex is at. And that's going to be important. If we cannot identify the correct location for the vertex, that's going to cause us to put the vertex angle in an incorrect location, and that's going to cause us some mathematical mistakes later on. Okay, moving on. In an isosceles triangle, where a leg and a base join together, another angle is formed. The angles that connect the legs to the base are called base angles. And of course, there are two angles that connect legs to the base. So there are two of them in our isosceles triangle. And as you can guess, they are located in those positions. But let me warn you once again, okay, being base angles does not have anything to do whatsoever with being on the bottom of the triangle. Base angles can be anywhere as long as they are connected to wherever the base is. Okay. Now, a little bit of review on basic information for side lengths and angle measurements. Okay, so you can probably get away with not writing this page down, but if I were you, I might go back and mark in my notes, maybe highlight this information in my previous notes. There's a connection in all triangles between the side lengths and the angle measurements. Okay, and that connection, you should remember, is that the largest sides are always across from the largest angles. The smallest sides are always across from the smallest angles. And if you have two sides that are congruent, which we will in an isosceles triangle, then the angles across from them are always congruent. Okay, so we're definitely going to see in an isosceles triangle, since we're going to have at least two sides congruent in our triangle, that is going to force at least two angles to be congruent in our isosceles triangle as well. All right, so let's have a look at an example. Find the values for the missing variables. Take a second and jot the triangle down. We'll start walking through it. Okay. Obviously, there is a lot of missing information. In fact, we have three variables inside of this triangle that are not known, and the instructions are to find the values. Okay, now let me just say this. Obviously, the variables that are in the triangle are in alphabetical order. You have an X, you have a Y, you have a Z. However, that has absolutely nothing to do with the order with which variables should or could be solved for. In fact, it may be the case at times where you cannot find the value for one variable without first finding the value for a different variable. So don't worry about necessarily X coming first, Y coming second, and Z coming last like you have to do it alphabetically. Simply do it in any order that you have access to solving the variables. Okay, so if something jumps out at you first, then go ahead and solve that first and then move forward. Personally, the X information in this problem shouts at me, okay, the legs of an isosceles triangle are congruent. They are even marked with tick marks in this particular instance for us. Okay, so it should be very easy to ascertain that the length of X is going to be equal to 5. Because of the tick marks. Very simple. Okay. Now, based upon that thinking that you have two sides that are congruent, there is another variable that jumps out at me at this point, and it would be the y. Okay. Right now, we are looking at angles across from congruent sides. And the rule is that angles across from congruent sides are also going to be congruent. So across from one tick mark, we have a 50-degree angle. So what is that going to mean for the angle across from the other tick mark? Also 50 degrees. Very easy. Okay. Now the only variable that's remaining is z. Okay. Now, I don't see anything that really jumps off the screen at me as far as finding z. However, a particular rule does come to mind. We know two of the angles in this triangle. We are trying to find the third angle that is in this triangle. Do we have a rule that speaks to us about the three angles in a triangle? Of course we do. The three angles in a triangle should add together to equal 180 degrees. So that's the formula or the equation that we ought to write. We have a 50 that we know, and we have a 50 that we know, and we have a z that we do not know, but the three of them should add up to equal 180 degrees. 50 plus 50 is obviously 100. That 100 would need to be subtracted to the other side. Z would be 80 degrees, 180 minus 100. Okay, so no big deal. There were three things to solve, but no one thing was really all that difficult. Now I have an example that I would like you to copy down, and I want you to give this one a try before you get to class on Monday. We will cover it in class to see if your answers were correct, but I do expect you to arrive at class with some answers. Find the values for the missing variables. This time there are only two missing variables. That does not necessarily mean the problem will be easier or harder. It simply means there's two pieces of missing information. Okay, so copy the diagram down and see if you can arrive at answers for X and Y. I appreciate you finding time to get your notes done for Monday's class. You have a test coming up next week, most likely on Thursday, so you need to be getting yourself ready for that. And I'll see you in class on Monday.